Okay, so in this video is actually the first part of a three-part series on the fundamental theorem of algebra. Now, the title is called Fundamental, so you better make sure you know it. And it is kind of difficult, so we're doing some high-power algebra here, so you might have to watch it multiple times, and as always, if you got questions, let me know. So pretty much what the fundamental theorem of algebra says, I'm not going to read this whole thing for you, but it only works for polynomials, okay? So that's number one. Number two, the polynomial is going to have a highest power, which we call n. And essentially what the fundamental theorem of algebra says, if you have a polynomial with power n, highest power n, then it's going to have exactly n solutions. Also, the fundamental theorem of algebra says that any n degree polynomial, so the highest power again is still n, it's going to have exactly n zeros. So exactly n solutions and exactly n zeros. That's what the fundamental theorem of algebra says. Once we know at least one real solution or one real zero, we can use graphing, synthetic division, or long division to find the other solutions or zeros. And these might be real numbers or might be complex numbers with the i's. We talked about this before earlier in the course, so if you need to go back and rewatch those videos, you might need to do that. Pause this and go back and do that now. Same thing with the synthetic and long division. That's been a long time ago, so be sure you refresh yourself before you go any farther. So in example 15, we have a function f of x, and it's a polynomial. The highest power is 3, and the equation fx equals 0 has 3 solutions. We know that from the fundamental theorem of algebra. Since the highest power is 3, we know we're supposed to have exactly 3 solutions. Might be real numbers, might be complex numbers, we don't know. One of the solutions is x equals negative 3. We want to find the other 2 solutions. Alright, so to start off with, since we have technology, what I'm going to do is to graph this equation. Now, instead of f of x, I'm putting in my polynomial, and that's going to go in y1. 0 is going to go in y2. And essentially, I'm just looking for the solutions like we've always done. So nothing new here. All right, so x cubed plus 3x squared plus 16x plus 48. I'm going to graph this. And I only see one point of intersection because, again, when I'm graphing y equals 0, that's just the x-axis, so second count. Option 5, first curve enter, second curve enter, yes. Oops, and I forgot to put my other function in y2, that's why nothing's happening. Sorry. So make sure you get both functions, y1, y2 now, second calc, option 5, first curve enter, second curve enter, yes. And I get x equals negative 3. Which is the solution we already knew. So that is only one of the 3 solutions. So unfortunately, graphing didn't really help out too much this time. All right, so we move on. I'm going to try synthetic division. Since I only know one solution, I'm going to use synthetic division. If I knew more than one solution, then I would use long division instead. Okay, so since I know one solution, this is going to be my king. The king always goes on the outside of my oven. I just put how much of each type of ingredient I have, and remember, if you're missing an ingredient, you have to put a 0 as a placeholder, otherwise it will not work. So I have 1x cubed, 3x squares, 16 x's, and 48 regular numbers. The pattern for synthetic division is we start by bringing it down, then we multiply, then we add. Now we just start repeating, multiply, add, add. So multiply, add, multiply, add. Remember, this last number is called the remainder. Since we know the remainder is 0, that means the factor x plus 3 is a factor of the polynomial. Okay, so that's going back to earlier in the course when we were talking about the factor theorem. If the remainder is 0, then all we have to do is take our solution and get everything on the same side. And that x plus 3 is a factor of the polynomial. That might come in handy later on, so as we watch these next couple of videos. We also know that these numbers represent the quotient. So this is what I'm going to use to do my work. We started off with x cubed in our original polynomial, so this 1 represents 1x squared plus 0x plus 16. Okay, and this is still equal to 0, okay, because that was what my original equation was. So I'm going to just keep saying equal to 0. I want to clean this up some. 1x squared plus 16 equals 0. Now I could graph this and try to solve it. However, since it's easy enough, I'm going to go ahead and just solve by hand. So minus 16 on each side. Cancel out, so I have x squared equals negative 16, but I don't want x squared, I want to know what x is. So I need to take the square root on each side. Well, when I take the square root of an equation, if my power is even, you need to remember this because we talked about this earlier in the course, if my power is even and I'm taking the square root, I have to do plus or minus. So that means I get x equals plus or minus the square root of negative 16. Now you can go ahead and split this up into two pieces if you want to. X equals the positive square root of negative 16, and x equals the negative square root of negative 16. Now, we can use our calculator. You should remember from earlier in the course, anytime you see a number underneath the square root that's negative, then we're going to have an I. So we need to make sure our calculator is in A plus BI mode. We've done this before. Again, if you need a refresher, go back and rewatch those videos. What I want to do is say the square root of negative 16. Make sure all of this is in the parentheses because it's all underneath the check mark. And I get 4i. So one of my solutions is 4i. And then I have negative square root of negative 16. Close it up. And I get negative 4i for my other solution. So I have three answers. X equals negative 3 was given to me. And then I had to use synthetic division and a little bit of algebra to find my other two complex solutions. Okay, so anytime you see an I, that's a complex solution. Again, the fundamental theorem of algebra says my highest power is 3, my original polynomial. That means I have to have three solutions. One that was given to me, 2, 3. I have three solutions. That's it for this example. Let's try one more. In example 16, where we have a polynomial function with highest power 4, so I know I'm going to have 4 zeros. That's from the fundamental theorem of algebra. One of the zeros is x equals negative 2. I want to find the other three zeros. So again, I'm going to start the process by graphing. Hopefully the calculator can help out some. So I'm going to go to y equals. This time I only have one thing to put in. I have this polynomial. So everything's just in y1. So x to the 4th plus 6x cubed plus 12x plus 8. It's 12x squared, excuse me, plus 8x. Alright, I want to graph that. And it looks like, so I have two zeros. So a zero is just a fancy name for the x-intercept, okay? So that's what I'm looking for, is where does the graph cross the x-axis? And the calculator actually do this for you. We're looking for zeros, so go second calc. This time option 2 for zeros, since that's what we're talking about. Now, it's going to ask you a couple questions. Left bound, your cursor just needs to be on the left side of where you think the x-intercept is. Right bound, your cursor just needs to be on the right side of where you think the x-intercept is. And then guess, you punch your cursor exactly where you think the x-intercept is. So one of the zeros is x equals negative 2. That's the one that was given to me. Okay, no big deal. I think I see another one right here, so I'm going to try to find that one. Second calc, option 2 for 0. Left bound, my cursor just needs to be on the left side of the 0. Right bound, my cursor needs to be on the right side of the 0. And guess, I just need to be right where I think it is. And the calculators tell me that another 0 is x equals 2. X equals 0. Alright, so now by graphing, I have 1 and 2 of the zeros out of the 4 total zeros I'm supposed to find. Now, since I have two zeros, instead of synthetic division, I'm going to go on and do long division. But first, I'm going to set this up. Since x equals negative 2 is a 0, I know that x plus 2 is a factor. Also, x is a factor. So, these two are going to be, I'm going to use these two factors, but before I do anything, I'm going to do some scratch work and then just do distributive property to say x squared plus 2x. I'm setting up my long division. So this is my divisor that I'm trying to come up with. Now I'm going to do long division. Again, we've done long division earlier in the course. If you forgot how to do long division, you need to go back and watch that video. Another thing about long division, in your divisor and in your dividend, the piece that goes underneath the doghouse, if you're missing a piece, you have to represent it with a 0 placeholder. So for instance, I did not have any 0 placeholders, so you need to put that in there. I have x to the 4th plus 6x cubed, but no, 12x squares plus 8x, but no regular numbers, so I have to represent that with a 0 placeholder. Now I'm ready to go through the long division process. Again, go back and rewatch those videos from a couple chapters ago if you need help with this. We'll still be here when you come back. I'm looking for how many times will x squared go into x to the 4th. It'll go in x squared times. Then x squared times x squared is x to the 4th. This is your double check. These first pieces have to match. If they don't, you've done something wrong. Then keep multiplying. So x squared times 2x is 2x cubed. That's a positive. X squared times 0 is 0x squared. And now the next step says we subtract. The first piece should always cancel out. Then you just subtract like normal. 6x cubed minus 2x cubed is 4x cubed. 12x squared minus 0x squared is still 12x squared. And now we just bring down the remaining pieces. So plus 8x plus 0. Now we're going to repeat the process. So long division, like synthetic division, we just start repeating the entire idea. Now I'm looking for how many times will x squared go into 4x cubed. It'll go in 4x times. And now I'm going to start multiplying again. So 4x times 4x squared is 4x cubed. Again, the first pieces have to match. 4x times 2x is 8x squared. And 4x times 0 is 0x. Now that we finished the multiplication, we start subtracting. The first pieces should always cancel out if everything's going correctly, and it is. Now we start subtracting like normal. 12x squared minus 8x squared is 4x squared. 8x minus 0x is still 8x. We bring down to 0. Now I'm looking for how many times will x squared go into 4x squared. It'll go in 4 times. And what I want to see now is I'm going to start multiplying. So 4 times x squared is 4x squared. 4 times 2x is 8x. And 4 times 0 is 0. Now I start subtracting. And what's going to happen here in this particular problem is everything's going to cancel out. So I have a remainder of 0. It's a remainder of 0 because x plus 2 and x both together, which we multiply to get x squared plus 2x plus 0, is a factor of our original polynomial. So that makes sense. Now what I want to do is just look at my quotient, which is sitting on top, and we're going to set that equal to 0 like we did in the previous example. We're going to say y1, y2, and hopefully we're going to see some points of intersection. Those points of intersection are going to be our zeros. So y1 is now going to be x squared plus 4x plus 4. y2 is going to be 0. I'm going to graph this thing, and I see one of my zeros is right here. Well, like we said in the notes just a few minutes ago, if you read it carefully, if a 0 occurs at a turning point, then it's a repeated solution or a repeated 0. So second count, option 5, first curve in our second curve in our guess. I get x equals negative 2 again. And since graphically that was a repeated, that 0 or that point of intersection occurred at a turning point, it's a repeated solution, so we have to count it twice. So we had the original one, x equals negative 2, that was given to us, the one that we found from the original graph, and now x equals negative 2 and x equals negative 2 again because that 0 occurred at a turning point. Those are our 4 zeros for this polynomial function. If you have any questions, I know this is kind of challenging, especially maybe with the division, synthetic and long. Let me know and go back and rewatch those old videos. That's it for this one.